Unit 6, rational functions. 6a is to find horizontal and vertical asymptotes and the equations of them. Equations of a vertical asymptote is x equals the number. Equations of the horizontal asymptote, or a horizontal line, is y equals the number. Horizontal is always y equals, vertical is always x equals. Example 1, find the equations of the vertical and horizontal asymptotes of the function. So first plug it into the calculator, graph it. I see there's a vertical asymptote on my graph. I go to the table, pick out some points, -6, -1, -4, -3, -2, 3, and 0, 1. And I graph it. I see at -3 there's an error. That's going to tell us one of our asymptotes. So at -3 I gotta make sure that there's something that's a vertical asymptote there. And then drawing in the graph, just make sure not to cross over that vertical asymptote. It looked like there was another asymptote somewhere along the y or x-axis. So graph it. Now to find the asymptotes, well, first we just found the one. We had x equals -3, there's an error. That's always a given that that's the vertical asymptote, one of the vertical asymptotes. Is that x equals -3. To find the horizontal asymptotes, you can take a look at the graph. It looks like there's a horizontal asymptote cut right through on the x-axis here. But another way to tell is if the coefficient of your numerator is bigger than the coefficient of your denominator. Sorry, how to find the horizontal asymptotes is all about the degree of the numerator and the biggest degree of the denominator. The degree of the numerator, there is no variables on there, but if I put a variable, it's x to the 0 power. And the denominator, the biggest degree, is x to the first. If the numerator's degree is smaller than the denominator's degree, the horizontal asymptote is always at y equals 0. So there you go. Example 2. For example 2, is again finding the horizontal and vertical asymptotes. But again, we put it into the calculator. Numerator and denominator are both in parentheses since they're binomials, more than one term. Graph it. I see, let's pick out some points. So I picked out 2 points. It was -3, 0, and 5, 2. And then I also see that there is a asymptote, looks like at 4. So that's at x equals 4. So then I can put a vertical asymptote at x equals 4 in. That's a vertical asymptote, so we can actually write that down. Vertical asymptote. And a vertical asymptote is always x equals, and it's 4. Find the horizontal asymptote, well, we should actually draw in this graph. Graph it. Just draw in the general shape. Make sure not to cross over certain asymptotes. Looks like it comes through here. Looks like there is a horizontal asymptote. How you find this horizontal asymptote is we look at the biggest, or the numerator's power. Here's x to the first, that's the biggest power, and the denominator's power, which is to the first also. In this one, both powers, numerator and denominator, is exactly the same. So what you end up doing to find the horizontal asymptote is you take the coefficients of the 2 biggest power, or 2 powers that are the same. So the horizontal asymptote is that y equals, and the coefficients are 1 on top and 4 on the bottom. So horizontal asymptote is at 1 and 4. Moving on to 6b, sketch the graph of the rational function, labeling all relevant information. Well, what is relevant? We're looking at domain, which are x values, discontinuities where the graph can't be. These are holes and asymptotes. A hole is a specific point where the graph isn't, where the graph's going on, and then there's a hole there. And x-intercepts where the graph crosses the x-axis. Let's jump right into example 1. When we put the graph or the equation in, make sure to put the denominator in parentheses since there's more than one term. It's a binomial. Going to graph this. Really can't see a whole lot. I'm going to go to the table, so second graph. I see that at 3 there must be a vertical asymptote, or there's a discontinuity there, I guess. X equals 3. So looking here, we know that x equals 3. There's a discontinuity. We don't know, I guess, that it's a vertical asymptote at this point. I'm going to search up and down and see if there's any other discontinuities. Go to like negative 15 to 15. That should cover anything you have to deal with. I don't see any other errors in here. So that's my only discontinuity is x equals 3. I go look at the graph, and it looks like there's a vertical asymptote coming through. I can see a vertical line. I can make up a little bit of the graph. We can actually zoom in on that portion of the graph. You can see it a little bit better. We can see that there's a vertical line there. That's a discontinuity. That's an asymptote. That's a vertical asymptote. So there are no other discontinuities, so there are no holes in this graph. The x-intercept, well, let's zoom back out. Find the x-intercepts. Does not look like there is one. It doesn't look like it's going to cross. No. Does not look like it crosses, so none. And domain is all of your x values. So if I look at the graph, all of my x values starting from the left, the graph, what's going to happen is there's going to be a vertical asymptote at 3. And then the graph comes from left here. Right along the asymptote. There's actually a horizontal asymptote at x equals 0. And that is there because the numerator's biggest power is 0. The denominator's biggest power is 1, which you just learned in 6a. Anytime the numerator's power is less than the denominator's, it has a horizontal asymptote at y equals 0. So we know there's another asymptote, horizontal asymptote right here. That's a quick refresher from the other, from 6a. Now the domain. One way to do this, the domain starts at negative infinity. So it comes from out here, and you can go all the way to 3. So negative infinity is less than x is less than 3. And then starts on the other side of 3 and it goes to the right forever and ever. So it starts at 3 again, it goes to x, and goes to infinity. Alright, our last example of the day is example 2. And again, we're finding the discontinuities and holes, x-intercepts, and domain. So find with this equation, put the numerator and denominator in parentheses. And we graph it. I can see a vertical asymptote. Find the points. I've already done this. And I graph it. I found the points -5, 2. I found the points -3, -4, -1, -2, and 1, 0. I graph this. Looks like there's a vertical asymptote at -2. We can check this. -2 and 0, there's 2 discontinuities. So we can, by looking at the graph, I can see that at -2, there's a vertical asymptote here. So the graph, looks like I have a point, oh, it should be -3, 4. The graph comes comes along here and here. So we have, now going back to discontinuities. So to find discontinuities, you look in the graph, I see there's two discontinuities, one at -2 and one at 0. So x equals -2 and 0. Now to distinguishing what is a hole and what is an asymptote, we look at the graph. You see at -2 there's a vertical asymptote. So that means at 0, there's no vertical asymptote there, that has to be a hole. If there are no vertical asymptotes where it is, that has to be a hole. So then at 0, there's actually a hole here. And x equals 0. And x-intercepts, well, we just said x equals 0. But our x-intercept is at x equals 1. For y equals 0, you can say x equals 1, or you can say 1, 0. That might even be better, coordinate 1, 0. Now for the domain, there's a couple of discontinuities. You pretty much just say as x is coming from -infinity, and our first discontinuity is at -3, so it's coming from -infinity to -3, and then it's coming from -3 to 0, and from the other side of that hole from 0 to infinity. That would be discontinuous holes, x-intercepts, and domain. How do you find them?